Hello and welcome back to my channel. Today I'm going to be taking you through the May-June 2020 exam for Pure Mathematics. That's paper 11. So we can get started. Question number 1. The sum of the first 9 terms of an arithmetic progression is 117. The sum of the next 4 terms is 91. Find the first term and the common difference of the progression. So right here, the piece of information that we have is that the sum of the first 9 terms is actually equal to 117. So that sum to 9 is 117. We've also been given that the sum of the next 4 terms is 91. Now, if we add these 4 terms to the first 9 terms, we have 13 terms in total. So the sum to 13 terms, or first 13 terms, should be 117 plus 91. So this is going to give us 208. Now, we know that the formula for sum of terms for an arithmetic progression is sum to n is equal to n over 2, 2a plus n minus 1d. So in our case, sum of the first 9 terms is going to be 9 over 2 of 2a plus 8d. The 8 is from 9 minus 1. So this is going to give us 117. I can simplify this equation by multiplying both sides by 2 over 9. So this side again by the same. So the 2's will cancel out and the 9 will cancel out. So I'll end up with 2a plus 8d on the left side. It's equal to 9 dividing into 117. It gets in 13 times, and 13 times 2, we get 26. So we have here an equation in terms of a and d. We've also been given that the sum of the first 13 terms is 208, and from the formula, that's going to be 13 over 2 of 2a plus 12d. And this is going to be equal to 208. And if I multiply both sides by 2 over 13, then the 2's will cancel, the 13's as well. So I'm left with 2a plus 12d is equal to, and I simplify this part, 13 gets into 208 16 times, and 16 times 2, that's 32. And this is the second equation. So I can solve the two simultaneous equations by elimination. So I'm going to subtract equation 1 minus equation 2. And doing so means I'll subtract 2a minus 2a to eliminate the a terms. Then 8d minus 12d, we get minus 4d. And 26 minus 32 gives us minus 6. And if we can divide both sides by minus 4, then we will have the value of d coming out as 1.5. If I take any one of the two equations, I can take the 2a plus 8d is equal to 26, and I substitute d into it, so that's 2a plus 8 of 1.5, it's equal to 26. So that's 2a plus 12 is equal to 26, and that's 2a is equal to 14 after subtracting 12 from both sides and dividing both sides by 2, we get a coming out as 7. So we now have the two solutions. A is 7, that's the first term, and d is 1.5, that's the common difference. That's what the question wanted us to find. And that's how we were supposed to do it. Let's scroll down to the next question. Question number 2. The coefficient of 1 over x in the expansion of kx plus 1 over x to the power 5 plus 1 minus 2 over x to the power of 8 is 74. Find the value of the positive constant k. So here, let's start with kx plus 1 over x to the power of 5. Now we know that the general term in the expansion of a plus b to the power of n is u sub r plus 1 is equal to n choose r, a to the n minus r, b to the r. Now for kx plus 1 over x to the power of 5, the general term will be 5 choose r, and kx to the power of 5 minus r, which is 5 minus r, and 1 over x to the power of r, like this. So we can deduce the coefficients in the general expansion as 5 choose r, that's the constant, and here we can have the constant k raised to the power of 5 minus r. So these are going to be the coefficients. And the x terms in the expansion are going to be only x to the power of 5 minus r, and also here 1 over x to the power of r. And this can be simplified: x power 5 minus r times x power of minus r, which is basically x to the power of 5 minus 2r if we add the powers. So all the x terms in the binomial expansion of kx plus 1 over x power 5 take the form x to the power of 5 minus 2r. But now since the x term is 1 over x, or x power minus 1, we can equate this to say x to the power of 5 minus 2r is equal to x power of minus 1. And therefore equating the powers, so 5 minus 2r is equal to minus 1. And we can solve for r. That's subtracting 5 from both sides becomes minus 1 minus 5, which is minus 6, and dividing by minus 2, we get r as 3. So the term that we want occurs when r is equal to 3. So the coefficient will come out as 5 choose 3, and k to the power of 5 minus 3, which is k squared, and 5 choose 3 is 10, so we'll get the coefficient of 1 over x to be 10k squared. So that's how we can find the coefficient of 1 over x in the binomial expansion of kx plus 1 over x to the power of 5. Now for the expansion of 1 minus 2 over x to the power of 8, so for 1 minus 2 over x to the power of 8, we can make use of the formula from the formula sheet for the expansion of 1 plus x to the power of n. So this is taken from the formula booklet. So it's likely that the term in 1 over x is going to come out as the second term, which is nx here. So by expanding, nx will simply be n, which is 8, of x, which is in this case minus 2 over x. And this gives us minus 16 over x. So the term in 1 over x is the second term in the expansion of 1 minus 2 over x to the power of 8. And this happens to be minus 16 over x. So this can be expressed as minus 16 of 1 over x. And therefore the coefficient is simply minus 16. So we now have two coefficients. We obtain the first coefficient as 10k squared. So 10k squared, and the second coefficient as minus 16. So this should be equal to, according to the question, this should be equal to 74. So it's all equal to 74. So I'll add 16 to both sides, so that's 10k squared is equal to 74 plus 16, and that's 90. Dividing by 10 both sides, we get k squared is equal to 9. And square rooting both sides, we get k is equal to plus or minus 3. However, from the information in the question, they want us to find the value of the positive constant k. So k should be positive, and therefore the value of k that we want is 3. And that's our answer here to question number 2. And that's how we do it. So let's now scroll down to the next question. Let's go to question number 3. It goes, each year, the selling price of a diamond necklace increases by 5% of the price the year before. The selling price of the necklace in the year 2000 was 36,000. Write down an expression for the selling price of the necklace n years later, and hence find the selling price in 2008. From the information we have in the question, we are starting with the value for the necklace, which I want to call Y0, to be 36,000. After year 1, the value of the necklace would have increased by 5%. So it's more like we're saying, in dollars, 36,000 increasing by 5% is the same as multiplying this by 1 or 5%, or simply 1.05. So this will be the new value after year 1. 2 years later, we'll be increasing the value from the previous year, again by the same percentage. So it'll be 36,000 multiplied by 1.05 squared. So this is going to continue all the way until we get to year n, which will generally be 36,000 multiplied by 1.05 to the power of n. So what we have here is the expression for the selling price of the necklace n years later. Again, the question says, hence find the selling price in 2008. So in 2008, that will be 8 years later from 2000. So that will be Y8. So n is equal to 8. So this will be 36,000 multiplied by 1.05 to the power of 8. I'll need a calculator for this. So with my calculator, I'll type in 36,000 multiplied by 1.05, and that's to the power of 8. And this gives me 53,188. So to 3 significant figures, this will just be 53,200. So I'll write it down. 53,200. So that's the amount for year 8. Okay, you can write it as a currency with a dollar sign. It's still fine. So that's the answer to part A. Then for part B, the company that makes the necklace only sells one each year. Find the total amount of money obtained in the 10-year period starting in the year 2000. So here we are considering a geometric progression, with first term being equal to 36,000. This is the information we have from the first part of the question, that the selling price of the necklace in the year 2000 was 36,000. So that's the first term of the GP. And again, R, which is the common ratio, we've been using it as 1.05. So for this GP, geometric progression, R is equal to 1.05. And here we're talking about a 10-year period starting from the year 2000. So it means that N is equal to 10. So if we use the formula for sum of the first n terms of a GP, which is A of R to the n minus 1 over R minus 1, then we'll be able to find the sum for the 10-year period. So we do sum to 10 is equal to A, which is 36,000, open bracket, that's 1.05, to the power of n, which is 10, minus 1, and we divide all this by R minus 1, which is 1.05 minus 1. So let's just use our calculator for the calculation. So what we're getting from our calculation is 452,804. So to 3SF, we'll just say 453,000. So that's what we get. So that's 453,000. And that's the total amount of money obtained in the 10-year period starting in the year 2000. And that's it for question number 3. Let's scroll down to the next question. Question number 4. So we have a graph here, and the question goes, the diagram shows the graph of y is equal to f of x, where f of x is equal to 3 over 2 cos 2x plus a half for 0 to pi. Those are the values of x. On A, state the range of f. Now we want the range of this function here, and it's a trig function. We know the original trig graph of y is equal to cos x, and we know that the range for the function cos x is within plus and minus 1. So y values between plus 1 and minus 1. So I think you can see that this graph here is simply a transformation of the graph of y is equal to cos x. And the transformation involves a stretch parallel to the y-axis and a stretch here again parallel to the x-axis. And here it's a translation by half a unit going up. So the two transformations that will affect the range, which are the y values, is the stretch here and the translation. So how will the stretch affect the y values? The stretch has factor of 3 over 2. So 3 over 2, and we multiply or transform the maximum and minimum values of cos x, that's plus or minus 1. And the other transformation affecting the y values is the translation, since our graph will be going up by half a unit. So that will be plus a half. We actually have two things here. We have minus 3 over 2 plus a half, and we also have positive 3 over 2 plus a half. And minus 3 over 2 plus a half will give us minus 1, and 3 over 2 plus a half will give us 2. And therefore, these two values will become the range of the function f of x. So it will be from minus 1 to 2. So this here is our answer. This is the range of the function. Let's scroll down to part B. A function g is such that g of x is equal to f of x plus k, where k is a positive constant. The x-axis is a tangent to the curve y is equal to g of x. So on part B, state the value of k and hence describe fully the transformation that maps the curve y is equal to f of x onto y is equal to g of x. So we want to use the piece of information that we have right here. Now, the new function g of x is f of x plus k. And if we're adding a constant to f of x, this represents a translation going up by k units. And to help us understand better, they say the x-axis is a tangent to the curve. So the situation here will be like, this is the graph of y is equal to f of x. So when we now have the graph of g of x, which is f of x plus k, it means this graph is rising up by k units. So the graph of g should now come out to be like this. It has been translated up by k units, since k is a positive constant, until the graph of g, this is the graph of g of x, now touches the x-axis once. So the x-axis is now a tangent to this graph. So we know that the minimum point of this graph, from the range we got it to be -1. So by how many units should it be translated up so that the x-axis is a tangent? That should be 1 unit, where k is equal to 1. So k is just 1 unit. So to answer the question, state the value of k. So k is 1. And it says, and hence describe fully the transformation that maps the curve y is equal to f of x onto y is equal to g of x. So we're saying it's a translation by 1 unit in the positive y-axis. So that's the transformation. Let's go on to part C. On part C, it goes, state the equation of the curve, which is the reflection of y is equal to f of x in the x-axis, and give your answer in the form y is equal to a cos 2x plus b, where a and b are constants. Alright. Now, we have the graph y is equal to f of x, and f of x, according to the information given, is 3/2 cos 2x plus a half. So I'll write it here. So if we're talking of a reflection of y is equal to f of x in the x-axis, then the transformation is represented by y is equal to minus f of x. So that's minus f of x is minus of 3/2 cos 2x minus a half. So therefore, the reflected graph should simply be y is equal to minus 3/2 cos 2x minus a half. And that's the solution right here. We can now move to the next question, and that's question number 5. The equation of a line is y is equal to mx plus c, where m and c are constants. And the equation of a curve is xy is equal to 16. On part A, given that the line is a tangent to the curve, express m in terms of c. Okay, so we're talking about the intersection of a line and a curve. In this case, the line is a tangent to the curve. So we have to combine the two equations. We have y is equal to mx plus c, and we have xy is equal to 16. So I'm going to substitute y into the second equation. So it means that we'll now be having xy, but for y I put mx plus c is equal to 16. So that's mx squared plus cx is equal to 16. So minus 16 is equal to 0. So I now have this quadratic expression here. So since the line is a tangent to the curve, it means that b squared minus 4ac should be equal to 0. Since the line is only touching the curve only once, so we only have one root right there. So a is the coefficient of x squared, so that's m. B is equal to the coefficient of x, so that's c. And c is minus 16 for the discriminant. So right here, b squared minus 4ac will be c squared minus 4 times m times minus 16. And we say this should be equal to 0. So that's c squared minus 4 times minus 16 gives us plus 64m, and that's all equal to 0. So they say express m in terms of c, which means I'll take c squared to the other side, so 64m is equal to minus c squared, and divide both sides by 64, so m comes out as minus c squared over 64. So the answer right here should come out as minus c squared all divided by 64. That's how we do it. We can now go on to part B. Given instead that m is equal to minus 4, find the set of values of c for which the line intersects the curve at two distinct points. So in this case, the discriminant b squared minus 4ac, since the line intersects the curve at two distinct points, it should be greater than 0. So I'll take the value of the discriminant, which we obtained in part A, to be c squared plus 64m is equal to 0. So that's c squared plus 64m is greater than 0. Now m is equal to minus 4, so it becomes c squared plus 64 of minus 4 is greater than 0, which is c squared, and 64 times minus 4 is minus 256, and that's greater than 0. Now we have a difference of two squares here, so this will give us c plus 16 and c minus 16. And we have two critical values, which are plus and minus 16. So with the critical values, I can simply make a small sketch. And this is the c-axis, and the graph is U-shaped. This is positive above the c-axis and negative below it. So we have minus 16 here and positive 16 here. So we want values of c such that c squared minus 256 is greater than 0. And greater than 0 means positive. So this graph is positive for values of c that are less than 16 and values of c that are greater than 16. So the solutions will be c is less than minus 16 and c is greater than positive 16. So we have these two solutions right here. And that's the answer to part B. Let us now look at question number 6. Functions f and g are defined for x is an element of all real numbers by f of x is equal to half of x minus a, and g of x is equal to 3x plus b, where a and b are constants. So on a, given that g of 2 is equal to 10 and f inverse of 2 is equal to 14, find the values of a and b. So here we've been given that g of 2 is equal to 10. So how do we handle this? First of all, I will work out g of 2, because for this composite function, g of 2 is an input into g, into the first g here. So I'll work out g of 2 first. So for g of 2, if I go to the function g, it's g of x is equal to 3x plus b, which means I'm inputting 2 in place of x. So g of 2 should come out as 3 of 2 plus b, and that's 6 plus b. So that's g of 2 here. And since g of 2 is an input into the function g, and we got g of 2 coming out as 6 plus b, so it will now be g of 2 is equal to, and we input g of 2, that's 6 plus b, into this, so it becomes 3 of 6 plus b plus b, like it is 3x plus b here. Simplifying, I get 18 plus 3b plus b, and that gives us 18 plus 4b. So this is the expression for g of 2. We also have another piece of information that f inverse of 2 is equal to 14. So we know that f of x, which I want to express as y, is half of x minus a. And I have to find the inverse of f. So I'll first have to make x the subject. So if I try to make x the subject, adding a to both sides and multiplying both sides by 2, I will get x is equal to 2y plus 2a. So I've just made x the subject here. And then I'll interchange the variables. So I'll have y is equal to 2x plus 2a, which means that f inverse of x is actually 2x plus 2a. So I now have the inverse function. And since I have the inverse function, and since f inverse of 2 is 14, it means I will substitute 2 for x. So for f inverse of 2, this will be 2 of, and I input 2 for x. So that's 2 of 2 plus 2a. So f inverse of 2 gives us 4 plus 2a. So we now have this for f inverse of 2. So from the information given in the question, g of 2 is equal to 10, which therefore means I can say 18 plus 4b is equal to 10, and I can solve this equation for b. So I'll subtract 18 from both sides, so I have 4b is equal to 10 minus 18, and that's going to be minus 8. And I divide both sides by 4, and if I divide both sides by 4, then b will come out as minus 2, and that's the value of b. And from here, the information given is f inverse of 2 is 14. So here, I'll equate f inverse of 2, which is 4 plus 2a, to 14. And so for a, so subtracting 4 from both sides, that will be 2a is equal to 14 minus 4, that's 10. And I'll divide both sides of the equation by 2. So a comes out as 5. So that's the value of a. So we now have our solutions. A is 5 and b is equal to minus 2. So we're done with part A. Let's now go on to part B. It goes, using these values of a and b, find an expression for g of f of x in the form cx plus d, where c and d are constants. So here, they want us to find g of f of x. So this is a composite function, and we know that f of x is an input into the function of g. So what is f of x? From the information given, f of x is half of x minus a. So that's g of a half of x minus a. So I'm inputting half of x minus a into the function of g. And what is the function g? The function g is 3x plus b. So it means I'll be having 3 of x, which is half x minus a, plus b, which is 3 over 2 of x minus 3a plus b. But you know, we had gotten a as 5 and b as minus 2. So therefore, since a is 5 and b is minus 2, then g of f of x will now be 3 over 2 of x minus 3 of a, which is 5, plus b, which is minus 2. So eventually we'll be getting 3 over 2 of x minus 15, that form 3 times 5. So minus 15 minus 2, that's minus 17. And this is the value of g of f of x. So that's the answer to part B. Let's scroll down to number 7. On number 7, part A, prove the identity 1 plus sine theta over cos theta plus cos theta over 1 plus sine theta is identical to 2 over cos theta. So this is a trig identity, and in order for you to prove an identity, you have to pick a side and simplify it until you get the other side. Here I'm going to choose the left hand side. So the left hand side, we have 1 plus sine theta divided by cos theta plus cos theta divided by 1 plus sine theta. Now we can simplify this. First, I'll have a common denominator with this 2. So that will be cos theta bracket 1 plus sine theta. That's the denominator. Then I'll multiply this 2. So that's 1 plus sine theta multiplying 1 plus sine theta. And again, I'll multiply this 2. So that gives me plus cos squared theta. So this is what we now have from combining the 2. So I'll expand the brackets. 1 plus sine theta bracket 1 plus sine theta. This is going to give us 1 plus 2 sine theta plus sine squared theta. So this is from the expansion of 1 plus sine theta bracket 1 plus sine theta. And this is going to be plus the cos squared theta that we have already. And it's all divided by cos theta bracket 1 plus sine theta. So now, sine squared theta plus cos squared theta, we know that from the identity, they give us 1. So it's more like these 2 are going to give us 1. And 1 plus 1, that's 2. So here we'll now be having 2 plus 2 sine theta divided by cos theta 1 plus sine theta. So what I'll do from here, since 2 is a common factor on the numerator, I'll factor out 2. So that will be 2 bracket 1 plus sine theta. And the denominator is there. And now you can see that I can actually cancel out 1 plus sine theta for the numerator and denominator. And I'm left with 2 over cos theta. And this is the answer. This is actually equal to the right hand side hence proved. So that's what they wanted us to prove, that it's all equal to 2 over cos theta, and that's exactly what we got. And we're done with question number 7. So let's go on to part B of the question. So part B goes, hence solve the equation 1 plus sine theta over cos theta plus cos theta over 1 plus sine theta is equal to 3 over sine theta. That's for 0 to 2 pi. So it's all in radians. So what we do here, we know that this whole thing here, we proved the identity on part A, and from the identity, this was equal to 2 over cos theta. And that's what's equal to 3 over sine theta. So this is what we have. Now from here, if I multiply both sides by sine theta, the sine theta will cancel out here. So we are left on the right side with a 3. Then from the left side, sine theta over cos theta, from the identity, this gives us tan theta. So we'll now be having 2 tan theta. So 2 tan theta is equal to 3. And we can say tan theta is equal to 3 over 2. So we can now use our calculator, since theta is equal to arctan of 3 over 2. So I'll take my calculator and make sure that the mode is right, that we're in radians. So we're now in radians. So I'll type in shift tan of 3 over 2, which is 1.5. And this gives me 0.983 to 3 decimal places. So that's theta is equal to 0.983. Now, if we look at the quadrants, you notice that theta is positive in the first quadrant and in the third quadrant. So the value of theta in the first quadrant is what we got, that's 0.983. But the value of theta in the fourth quadrant is going to be theta plus pi. So that's going to be 0.983 plus pi. And if we add 0.983 plus pi, we get 4.12 to 3 significant figures. So that's 4.12. So we are saying the values of theta, we have 0.983 and 4.12. These are the two values of theta, and that's the answer to this question here. Let us now go to the next question. Question number 8 goes, in the diagram, ABC is a semicircle with diameter AC and center O and radius 6 centimeters. The length of the arc AB is 15 centimeters. The point X lies on AC and BX is perpendicular to AX. Find the perimeter of the shaded region BXC. So we have all this information describing what's on the diagram here. And they want us to find the perimeter of the shaded region right over here. So to find the perimeter of the shaded region, we shall need to know what BX is, what XC is, and what the length of the arc BC is. Now to help us do that, let us start with the sector A or B, so this whole sector here. And we're going to use this big arc to find the value of this angle here. So we know the formula for length of arc to be r theta if theta is in radians. And the length of the arc AB is 15. That's equal to r, which is 6, times theta. Which means that if we divide both sides by 6, we get theta being equal to 15 over 6, which is the same as 2.5. So we now know here that this angle here is 2.5, and that's in radians. Now, if this is 2.5, then the angle adjacent to it is going to be pi minus 2.5. So we are saying angle BOC is pi minus 2.5 radians, and this is equal to 0.642. So that's 0.642. So we now know what BOC is. Now with this value of BOC, we can now calculate the length of BX. Now if you look at BX is part of this triangle. And for this triangle, we know that OB is 6 centimeters. So to find BX, we know that BX for this right angle triangle is the opposite side. So we can say BX is equal to 6 sine of the angle 0.642. And let's type that in. So that's 6 sine 0.642. And this gives us 3.59. So that's 3.59. That's in centimeters. So I'll highlight BX here. So now that we have BX, we may now need to know how to find the arc BC. So to find the arc BC, we can use the formula for length of arc, which is length of arc is r theta. R in this case is 6, and theta is BOC, which we got to be 0.642. So let's work out the length of the arc BC. So we are saying the length of the arc BC should be r theta. R is 6 and theta is 0.642. And if we multiply the two, we get that's 3.852. So that's 3.85 for us. So this is BC. I'll highlight it. So we now have BX and we have BC. We're now left with the small part XC to complete the perimeter of the shaded region. Now to get XC, we have to first know what OX is and subtract it from the length of OC. So to get OX, which is the adjacent side of this right angle triangle, we can use cos. So for OX, we can say OX is hypotenuse, which is 6, and that's cos of the angle BOC, which is 0.642. So that's how we work out OX here. So to get the adjacent side, we say hypotenuse cosine of the angle. So it's 6 cos pi minus 2.5, which we got to be 0.642. So the hypotenuse cos, so that's 6 cos 0.642. So I'll type it in. And this gives me 4.805. So that's 4.805 4.805. And now since we know that OX is 4.805, we can subtract that from 6 because OC is 6. So if we subtract OX, then we are left with what we want, which is XC. So if we say 6 minus the value we got for OX, we get XC. So that'll be, for XC, it'll be equal to 6 minus 4.805. And this gives us 1.193. So we now have XC. Now, to get the perimeter of the shaded region, we now have everything. We have BX, we have BC, and we have CX, or XC. So we can now just add the 3. And these are the values that I've highlighted there in red. So the perimeter should come out as BX, which is 3.59, plus BC, which is 3.852, and that's plus XC, which is 1.193. So if we add the 3, we get P as 8.64. So P is 8.64, and that's in centimeters. And that's our answer here. Let us look at question number 9. The equation of a curve is y is equal to 3 minus 2x to the power of 3 plus 24x. So on A, find expressions for dy by dx and d squared y by dx squared. So here, we are going to start with the derivative dy by dx. And to differentiate y, we're going to start with bringing down the 3. So that will be 3 here. Then finding the derivative of 3 minus 2x, then that's minus 2. And then I write down 3 minus 2x just as it is. Then the power is to the 3 minus 1, so that's squared. And that's plus 24x. If I differentiate it, I just get 24. So this is how I do it. So 3 times minus 2 is minus 6. Then 3 minus 2x squared plus 24. So this is the first derivative of y. Then for the second derivative, I'm going to differentiate the first derivative. So minus 6 is already here. Then I bring down the 2. Then differentiate 3 minus 2x. I get minus 2. Then I write down the 3 minus 2x. Then 2 minus 1 is 1. And the derivative of 24 is 0. So we get nothing there. So the second derivative will come out as minus 6 times 2 times minus 4. That's 24, bracket 3 minus 2x. So this here is the second derivative. Let's go down to part B. Find the coordinates of each of the stationary points on the curve. So we know that the stationary points occur when dy by dx is equal to 0. So what did we get for the derivative? We got the first derivative as this. So we're going to take the value we got for the first derivative, which is here, and equate it to 0. Now we can solve for x. So I'll subtract 24 from both sides and divide both sides by minus 6. So I'll be having 3 minus 2x squared, and it's minus 24 over minus 6. So I'll now be having 3 minus 2x squared is equal to minus 6 into minus 24 is 4. From here, I'll square root both sides. So square root for that side and square root for this side. So I'll be having 3 minus 2x is equal to plus or minus 2. So I can actually solve for x from here, and I'll get x is equal to minus 3 plus or minus 2, all divided by minus 2. So we have two x values. X is equal to minus 3 minus 2 over minus 2, or x is equal to minus 3 plus 2, all divided by minus 2. So minus 3 minus 2 is minus 5, and divided by minus 2, we get 5 over 2, or 2.5. And then for here, minus 3 plus 2 is minus 1, divided by minus 2, we get x coming out as a half. So we have two x values here. X is equal to 5 over 2, or 2.5, and x is equal to a half, or 0.5. Now that we have our x values, we'll also need to know what the y values are so that we can have the full coordinates. So I'll take the original equation of the curve here, and that's what we're going to use to find the y values. So here's the equation, the original equation, which means that I will substitute 5 over 2, or 2.5, into this equation here. Let me just use a calculator for quick working. So when x is 5 over 2, so that's 5 over 2 store x. Okay, so that'll be now open bracket 3 minus 2x to the power of 3 plus 24x, and this will give us 52. So the y value when x is equal to 5 over 2 is 52. So y is 52 here. And when x is equal to half, that's a half, and we store that in x. So that's 3 minus 2x to the power of 3. So open bracket 3 minus 2 of x to the power of 3. And that's plus 24x. And this gives us 20. So y will be 20. So the coordinates will be 5 over 2 and 52, and we'll be having half and 20. So these are the two coordinates here. Then for part C, determine the nature of the stationary point. Now to determine the nature of the stationary point, we have to find the value of d squared y by dx squared to see whether it's going to be positive or negative. So for d squared y dx squared, the second derivative, we got it as this. That's 24 bracket 3 minus 2x. So this here is the second derivative. Now we know that for the point 5 over 2 and 52, x is 5 over 2, or 2.5. So we substitute that into the second derivative. So that'll be 24 bracket 3 minus 2 of 5 over 2. So we simplify it as 24 bracket, and here the 2's will cancel. So I'll now just be having minus 5. So 3 minus 5, that's minus 2. So that's minus 48. And since minus 48 is negative or less than 0, we can therefore conclude that it's a maximum. And then now for the point half and 20, the second derivative will be 24 of 3 minus 2 of the x value, which is a half. So that will be 24 bracket 3 minus 1, which is 24 times 2, which gives us positive 48, which is greater than 0. So since the second derivative here is proven to be positive, we can therefore say hence it's a minimum. So that's the nature of the stationary points. So we're done with this question, and now let's scroll down to question number 10. The coordinates of the points A and B are -1 and -2 and 7, 4 respectively. So on A, find the equation of the circle C for which AB is a diameter. So we have a circle here, and we are hearing that we've got 2 points forming a diameter. So one of the points is -1, -2, and the other one is 7, 4. So we should be having the center here, which I want to call C. So we need to find the equation of the circle. Now, to find the equation of the circle, we only need 2 things. We need to know what the coordinates of the center are and what the radius of the circle is. So let's start with the coordinates. The coordinates of the center C here should be the midpoint of the 2 points, A and B, because we have A here and we've got B here. So that will be for the center. We can say it's the midpoint. So we add the x coordinates and divide by 2, then the y coordinates and divide by 2. This gives us -1 plus 7, that's 6, and 6 divided by 2, that's 3. Then -2 plus 4 is 2, and 2 divided by 2 is 1. So the coordinates of the center are 3, 1. So now for the radius, let's say r squared. We can use A and C, so we can use AC squared to get the radius squared. So that will be, using the coordinates of A and the coordinates of the center C, we can have -1 minus 3 squared plus -2 minus 1 squared. So this will be -4 squared plus -3 squared, which is 16 plus 9, and that gives us 25. So r squared is 25. So for the equation of the circle, we will now just say it's x minus the x coordinate of the center, that's 3 squared, plus y minus the y coordinate of the center, which is 1 squared, and that's equal to r squared, which we got to be 25. So this is the equation of the circle right here. We can scroll down now to part B. Find the equation of the tangent T to circle C at the point B. So here we're saying we have the circle and we have the point B here, and we want to find the equation of the tangent to the curve at B. So this is the situation here. The tangent is T. Okay, we already have the coordinates of B, and the coordinates of B we have been given as 7, 4. So we have 7, 4 here, and we also know the coordinates of the center, which are 3 and 1. So to find the equation of the tangent, we will need to know the gradient of the tangent. So we start with finding the gradient of the radius. So for the gradient of the radius, we're going to say it's going to be 4 minus 1 divided by 7 minus 3, and that gives us 3/4. So since we get 3/4 here, and we know that the tangent is perpendicular to the radius, we can therefore conclude that the gradient of the tangent T is the negative reciprocal of this, so it comes out as minus 4 over 3. Remember, the product of the gradients of perpendicular lines should be minus 1. So we get the gradient of t as minus 4 over 3. So for the equation of the tangent, we can therefore say y minus the y coordinate, which is 4, is equal to the gradient, which is minus 4 over 3, bracket x minus the x coordinate, which is 7. I'm using y minus y1 is equal to m of x minus x1 to find the equation of the line here. And now we'll now be having y minus 4 is equal to minus 4/3 of x plus 28 over 3. So if I multiply all the terms by 3, so times 3 here, times 3, times 3, and times 3, I'll be having 3y minus 12 is equal to, cancel, minus 4x plus 28. And this translates to 3y plus 4x is equal to, and adding 28 plus 12, we get 40. It's equal to 40. And this becomes the equation of the tangent. So that's it for part B. The last part is part C, which goes, find the equation of the circle, which is the reflection of circle C in the line T. So for this one, I'll take the sketch that we had already made in part B and place it here. So according to the question, we want to find the equation of the circle, which is a reflection of the circle C in the line y is equal to t. This means that it's a circle that is going to be like this, so it's a reflection. So t is the mirror line. So here, let me just erase this to create some space. So the coordinates of the center of the reflected circle, we don't know them yet, so we can call them A, B. And if you look at the situation, you can notice that the point B, which is right here, so B is right over here, is the midpoint of the center of this circle and of the reflected circle. And the coordinates of B are 7, 4. So the coordinates of B are 7, 4. So in order for us to find the coordinates of the center of the reflected circle, we can use the fact that the point B is the midpoint of the two centers. So we can say 3, that's the x coordinate here, plus A over 2, and 1 plus B over 2 should give us the midpoint, which is the point B, with coordinates 7, 4. Which means 3 plus A over 2 should be equal to 7, and 1 plus B over 2 should be equal to the y coordinate, that's 4. So here we can solve for A, so that's 3 plus A is equal to 14, multiplying both sides by 2, and subtracting 3 from both sides, A comes out as 14 minus 3, which is 11. And for here, multiplying both sides by 2, we get 1 plus B is equal to 8, so B is equal to 7. So we now have the coordinates of the center of the reflected circle, which are 11 and 7. The radius of the reflected circle should be the same as the radius of the original circle. So the radius of the original circle will be obtained in part A, that r squared is equal to 25, which means r, the radius, is 5. So the same radius is what we're going to use for the reflected circle. So r is equal to 5, or r squared is equal to 25. So we can say x minus 11 squared plus y minus 7 squared is equal to r squared, which is 25. So this becomes the equation of the reflected circle. Let us now look at question number 11. The diagram shows part of the curve y is equal to 8 over x plus 2 and the line 2y plus x is equal to 8, intersecting at points A and B. The point C lies on the curve and the tangent to the curve at C is parallel to AB. So on A, find by calculation the coordinates of A, B, and C. So right here, I'm going to start with the coordinates of A and B. For the two coordinates, since these 2 points are the points of intersection of the line and the curve, I'll have to solve the two equations, that is the equation of the line and the equation of the curve, simultaneously. So what I'll do is, just by looking at the two equations, I'm seeing that I can actually substitute the equation of the curve into the equation of the line. So I'll be solving the simultaneous equations by substitution. So we're saying here, since y is equal to 8 over x plus 2, I can substitute into the second equation. So that will be 2 of 8 over x plus 2 plus x is equal to 8. So I've just substituted this for y. So I'll continue simplifying. So 2 times 8 will give me 16. So that's 16 over x plus 2, and that's plus x is equal to 8. Now if I multiply all the terms by x plus 2, multiplying x plus 2 here, I get 16, and that's plus, and x times x plus 2, I just get x bracket x plus 2, and 8 times x plus 2, I get 8 bracket x plus 2. So let me continue simplifying. So this is going to give me 16 plus x squared plus 2x is equal to 8x plus 16. And I'm going to take everything to one side. So I have x squared here already. And then I'll subtract 8x from both sides. So that will be 2x minus 8x. So that will give me minus 6x. So this 8x is no longer on the right side. I also subtract 16 from both sides. And since 16 is appearing on both sides, we get 0. So we're only left with x squared minus 6x is equal to 0, which is x of x minus 6 is equal to 0. And therefore, these two factors equated to 0 will give me x being equal to 0 or x being equal to 6. So I'm going to make use of this information to also get the y values. So we have x values here as 0 and 6. So we now need the y values. Okay, so I can use any one of the two equations. Let's use y is equal to 8 over x plus 2. So we're saying y is equal to 8 over x plus 2. So when x is equal to 0, we can say that's 0 plus 2. So that's like 8 divided by 2, and that's 4. So here we've got 4. And when x is equal to 6, the equation will give us y is equal to 8 over 6 plus 2. 6 plus 2 is 8. So 8 over 8, that's 1. So here, the y coordinate is 1. So therefore, the coordinates of A and B are going to be, for A, I think you can notice that A is on the y-axis where x is 0. So here, this should be the 1 with 0, 4. So that's 0 and 4. And for the point B, we'll be having 6, 1 for the coordinates. So we now have the coordinates of A and B. Now, let us see how we can find the coordinates of the point C. Now, the point C is on the curve y is equal to 8 over x plus 2. And from the information given in the question, the point C lies on the curve and the tangent to the curve at C is parallel to AB. So there's a tangent at C, a line that touches C once, and this is the line here. And we're hearing that it is parallel to the line AB. Now we know that parallel lines have equal gradients. And if you look at the line 2y plus x is equal to 8, which can also be expressed with y subject as y is equal to minus a half of x plus 4, you can see that the gradient is the coefficient of x, which is minus a half. So the gradient of the line AB is minus a half, and that should be also the gradient of the tangent at C, since they are parallel. So I'll use that fact to say we have the gradient as minus 1 over 2 for that tangent. We can also make use of the gradient function of the curve. Since y is equal to 8 over x plus 2, we can actually work out the gradient function. So y is equal to 8 over x plus 2 is 8 of x plus 2 to the power of minus 1. So the gradient function of the curve is equal to 8 of minus 1 of x plus 2 to the power of minus 2, which is minus 8 over x plus 2 squared. So this is the gradient function of the curve. So at the point C, the gradient function will be equal to the gradient that we got to be minus half. So that's minus 8 over x plus 2 all squared. So we can now work this one out. Cross multiplication will give us x plus 2 all squared, and 2 times 8, that will be 16. Then we can square root both sides, so x plus 2 will come out as plus or minus 4, which means then that x is equal to minus 2 plus or minus 4. So we have got two values here, that is x is equal to minus 2 minus 4, which is minus 6, or minus 2 plus 4, which is 2. But you see here, the x value or the x coordinate of the point C shows that it's actually a positive value. So we will take the positive value, and therefore we'll take x to be equal to 2. So we're saying x is equal to 2. When x is equal to 2, then what is y? We can use the equation of the curve. The equation of the curve is y is equal to 8 over x plus 2. So we'll substitute the x value 2 into that. So y will be 8 over 2 plus 2, which is basically 8 over 4, which is 2. So therefore, the coordinates of C are going to be 2 and 2. And that's our answer here. So we now have the three coordinates, the coordinate of A here, the coordinate of B, and the coordinate of C. So this is what we have. We can now scroll down to the next part of the question, and that's part B. Part B goes, find the volume generated when the shaded region bounded by the curve and the line is rotated through 360 degrees about the x-axis. So let's go back to the diagram. I'll refresh it. So here it is. So it's the region, the shaded region, that is going to be rotated through 360 degrees about the x-axis. Okay, so the limits within which we're going to perform the rotation are 0 here, and the x-coordinate of b. Now, we've gotten b to be 6, 1. So the x-coordinate of b is 6. So this means for us that the upper limit here will be 6. So to get the volume generated, when this region here is rotated through 360 degrees about the x-axis, I will first have to find the volume formed when the line 2y plus x is equal to 8 is rotated through 360 degrees. So I'll start by rotating this line, and then I'll subtract the rotation of the curve about the x-axis again. So let's start with this 2y plus x is equal to 8. So we have 2y plus x is equal to 8. So we're saying for this, the volume of revolution, the formula goes, is pi integral from the lower x limit to the upper x limit of y squared dx. Now, for this equation, we can also express it with y subject as y is equal to minus a half of x plus 4. So we can actually now work out the volume of revolution by saying is pi times the integral of the limits. We've got 0 and 6, and that's of y squared. So that will be minus a half of x plus 4, and that's squared, and that's pi dx. So let's continue simplifying. So minus half of x squared is a quarter x squared, and that's plus 2 times the product of these two, which is minus 4x, and 4 squared is 16, and that's pi dx. So we can now integrate. So we'll be having the integral of a quarter x squared will give us 1 over 12 of x to the power of 3. And if we integrate minus 4x, we get minus 2x squared. And integrating 16, we get 16x. And the limits are 0 to 6. We can now substitute. So here, substituting 6, we'll be having a 12th of 6 cubed, and that's minus 2 of 6 squared, plus 16 of 6, and that's minus, and we substitute 0 into this. So substituting 0 into this will just give us 0. So we'll now need to simplify what we got right here. I might just need the help of a calculator. So overlay we get 42 pi. So that's the volume of revolution when the line is rotated about the x-axis. Now we want to rotate the curve about the x-axis. So we take the equation of the curve, that's y is equal to 8 over x plus 2. So we're saying for y is equal to 8 over x plus 2. This will be, the volume will be pi integral from 0 to 6 of 8 over x plus 2 all squared by dx. So this is pi times the integral of 64 over x plus 2 all squared by dx from 0 up to 6, which is the same as pi, times the integral from 0 up to 6 of 64 of x plus 2 to the power of minus 2, and that's pi dx. So this is going to give us pi, and here we'll be having 64 of x plus 2 to the power of minus 2 plus 1, that's minus 1, all divided by minus 1 from integrating, and we can simplify this to pi of 64 over x plus 2. That's minus here, and that's 0 up to 6. So we substitute 6 into this. So let's do that. We'll use the additional space. So that will be here, pi of, substituting 6, that will be minus 64 over 6 plus 2, which is 8. And that's minus, substituting 0, that will be minus 64 over 0 plus 2 will just be 2. Like this, which is pi of 8 into 64, that's minus 8, and that's plus 2 into 64, that's 32. So minus 8 plus 32, that's 24. So we have 24 pi here. So we now have the volume generated by the curve. So to get our answer, we're going to take the volume generated by the line, which we got to be 42 pi, and the volume generated by the curve, which we got to be 24 pi, and we subtract them. The volume is going to come out as 42 pi minus 24 pi, and this gives us 18 pi. And that's the solution here for the volume generated by the shaded area. So that's how we do it. And that, my friends, concludes the paper for May-June 2020, paper 11. Thank you